No problem. But I didn't.
All right.
I'm working on my muscles.
All right. Today we're going to jump into the next section. After 3 fun days on the chain rule, it's time to move on. I know.
They found that on the ground.
No.
Yes.
Implicit differentiation. Oh, it's not so bad.
Somebody's going to start throwing things in the head.
Implicit differentiation will really involve ideas of the chain rule, but it'll be really simple things that we chain on. But yeah, we had to talk about chain rule first because there's elements of chain rule in this. Implicit differentiation is what you use to differentiate something when the dependent variable is difficult to isolate. Math, science, you know, they see each other off and on. By the way, the dependent variable, what do we usually use for the dependent variable? Often. X or Y?
Why?
Y, yeah. So if the Y or the function, the f of whatever, is difficult or impossible to isolate, you probably want to use this to differentiate. And all implicit differentiating really is just differentiating term by term. Even if the terms are kind of ugly looking. Ugly terms are terms too. Some people might look at x cosine x and think, ugh. And some people might look at x cosine x and say, aw. And some people might look at x cosine x and go, rrr. I'm in the third of those camps, but that's my own personal taste, I guess.
This is little.
Judgment?
Absolutely.
It's just that when you differentiate a term that has both an x and a y in it, you're going to have product rule going on sometimes if you're differentiating x, y as a product. Something to keep in mind as you do this. The derivative with respect to x of x is what?
1.
1. What?
Remember? I wrote remember instead
Oh,
of remember.
I thought I wrote that because that sounds like something I do.
I forget letters.
The derivative of x with respect to x is 1. But, and this is going to come up, from time to time, the derivative with respect to x of y is not 1. It's only, the variable derivative is only 1 if that's what you're differentiating with respect to. If you're not differentiating with respect to y, then the derivative of y is actually dy over dx. What you see is what you get.
What if it was what if it was d over dy?
of y? That would be 1. Okay. Or what's kind of a cute little nickname we give to derivative of y with respect to x?
I mean,
That's kind of what it means, but like, can I ask this without just telling you the answer?
Might as well just tell us.
Yeah, I was gonna say, you could just test these.
What's the derivative of f? Paul? F prime. Okay. So another name for derivative of y would be y prime. That's not an exclamation point. That's a prime and a period after it. It's not y, it's y prime. And a one-main sentence. At this point, I feel like anything I do is just forcing it. Let's look at an example. We want to find the derivative of y with respect to x.
Why don't you give yourself some time so you can add to it, so that you're standing there.
And propose.
Yeah, it's like, that's my favorite part. You just stop, look at the camera, and then you go. Because you know you're going to have to edit it.
I like how you say it's our favorite part as if you've discussed it with many people.
Well, it's multiple people in my head.
Oh, you
There's like
would.
42 views.
He's lost
See,
his
right
mind.
now you're standing away from it, so you have to edit this, and you're not saying from it.
He has multiple people
I'm
in
leaving
his
this on
head.
there because this is making me look bad. Okay. We want to find the derivative of y with respect to x for this equation. And truthfully, this is written what they call, this is not written explicitly. If it were written explicitly, we would have y equals blah. The y would be isolated. The dependent variable would be isolated. And that's what we did. I can't talk. That's what we've been doing so far this year. Everything's always been f of x equals blah. And the f of x was always isolated. Here we've got y squared. We could isolate this y, but we don't have to. So I'm going to show you how to do this implicitly so that you don't have to first get the y isolated. I'm just going to differentiate term by term. So if I'm going to differentiate y squared, it's 2y. Now, to the first power, because the power drops by 1. Technically, I have to chain on the derivative of the y, because the y is the quantity that's being squared. And normally we disregard that. If it's an x here, we kind of just skip it. We say, well, the derivative of x would just be 1. But that's because we're differentiating with respect to x. Here, we're differentiating with respect to x, but the variable we're concerned about isn't x, it's y. Which means we actually need to chain on the derivative of y, which we could call y prime, right? So whenever you differentiate something with y in it, you're going to have to remember to chain on its derivative, which is going to be, we can call it y prime. Or you can call it dy over dx if you want to do that. Plus, now we can move on to the next term. 3x is going to have a derivative called 3. And now don't get too worked up. Well, don't I have to chain on the derivative of x? Well, okay, fine. The derivative of x is 1. Chain that. That wouldn't bother though. And then we keep right on going. We take the derivative on the other side. That's 0. That's 0. Leave me in. And ultimately, we want to get dy over dx. So what is it that we need to isolate? The y prime. Yeah, this is another way of saying y prime. This is the official name. When its mother's mad at it, it calls it dy over dx, get over here. But most of its friends just call it y prime. But it means the same thing. So let's isolate y prime.
So, -3 over 2y.
Okay, subtract the 3, it'll give you a -3.
2y.
Divide off the 2y, yep. There you go. you just hold on.